Podcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to today's webinar on managing the performance of applications in the microservices era. This is Christina Cardoza, news editor of SD Times. Before we get started, I have a couple of housekeeping announcements. First, if at any time you have questions about or during the presentation, you may submit them using the control panel's question tab. Secondly, this webinar will be recorded and available on demand through the sdtimes.com website in about 24 hours after the event. We will also have two poll questions asked during today's presentation that the presenters will go over later. I'm going to kick up the first one right now, which is, how would you characterize your company's use of microservices? Please pick from one of the following while we get things started. Here at SD Times, we've been writing about the different approaches organizations are taking to achieve better reliability, scalability, and productivity. By now, the benefits of moving to a microservices architecture have been well established, but with any approach, it comes with its own set of trade-offs and complexities. Today's webinar will talk about how to effectively manage the performance of microservice-based apps. With us today, we have Tyler Wells, Director of Engineering at Twilio, where he oversees the programmable video and SDK teams. Prior to Twilio, Tyler has held leadership and engineering positions at a number of real-time communication-related companies. Also with us today is Dennis Chu, Director of Product Marketing at Lightstep. Prior to Lightstep, Dennis has held leadership, product management, and engineering positions in cybersecurity and software testing companies. I'm going to close out the first poll now, so if the attendees could submit their final answers, I will throw it over to you, Tyler.
Thank you, and good morning. My name is Tyler Wells. I'm a Director of Engineering here at Twilio. I've been here for a little over 4.5 years, before that Skype, and a few other smaller companies, but all with a single thing in common, real-time communications. Let's talk a little bit about Twilio. Twilio was founded in 2008 on the basic premise that software would fundamentally transform how the world communicates. Our mission is to fuel the future of communications. We lower engineering costs with our flexible, scalable communication APIs and allow businesses to easily build relevant and contextual messaging, voice, and video capabilities directly into their software. Research shows that software applications increase user adoption and utilization rates when conversions with users take place within the application itself. This translates to lower cost, new revenue opportunities, and improved operational efficiencies. Thousands of global businesses, including ING Bank, Morgan Stanley, Netflix, and Salesforce, incorporate Twilio APIs into their products to better engage with their customers. We have more than 1,000 employees with headquarters in San Francisco and other offices in Bogota, Dublin, Hong Kong, London, Madrid, Malmo, Mountain View, Munich, New York City, Singapore, and Tallinn. We're a culture of small teams. Our small teams are focused specifically on products and services. We try to align accountability, responsibility into those teams. We don't have centralized QE, SRE, Ops, or a NOC. Each team owns their service end to end and across those disciplines. We always strive for an autonomy of team that's aligned with responsibility for product production incidents. Again, like I said, we don't have a team of hardened SEs to deal with incidents or incident handling. All of that is embedded into our teams, and they're basically enabled in order to deal with those types of incidents inside the teams themselves. Let's talk a little bit more about why Lightstep and how Lightstep has helped us realize some of the issues that we faced with being cloud native. So Twilio was born and raised in the cloud, and we've always been built on top of distributed microservices. They're at the heart of our platform, which is made up of composable discrete services that have responsibility of a single feature or function. Services and components will be loosely coupled with a clean separation of concerns. Services can be spread across availability zones, AWS services, and AWS regions. Let's dig into some of the challenges of operating an infrastructure like this. Companies trust Twilio to power their communications with customers. If there are service interruptions or high latency in our systems, it impacts our customers and their end users. Application performance and reliability is critical in maintaining customer relationships. We're in the business of selling trust, and the ability to identify and resolve system issues quickly and efficiently is a huge priority for us. Our vision is to deliver a flawless experience to the millions of developers registered on the Twilio platform, as well as provide additional service and insights for premium clients. We typically target 5 nines of availability and 5 nines of success. Generally speaking, the 5 nines is discipline and not luck. And as our architecture has grown to more than 40 core services, it experienced engineering growing pains that are typical of a high volume, high performance distributed systems. It's simple to track and segment data when you have a small number of services, users, and tags, but as an engineering system scales and the number of unique values in data increases, so does the cost and difficulty of identifying specific system issues. So we're constantly challenged with delivering trust and reliability. So let's look at how we aim to achieve this. We realized that quickly detecting and mitigating performance issues affecting our premium customers wasn't going to work with traditional practices. Setting up service level agreements, or SLAs, alerts on a customer by customer basis using approaches like log data alerting was cost prohibitive due to the dramatic increase in logging data volumes associated with our transition and running microservices. We wanted to be able to identify traces of specific noteworthy events, but traditional approaches like centralized logging were simply not the right solution. Logging solutions can provide information about who, what, and where things happen, but Lightstep XPM answers why things happen and helps us to do root cause analysis very quickly. We had plenty of what, but it was hard to envision and assemble the why, and this is where Lightstep really helped us out. We explored several options to reinforce our application performance management strategy. The team scoped that it would take at least 6 months and 2 full-time engineers to build a very simplistic in-house system. The maintenance of that basic system would also require 10% of the developer's time moving forward. Plus, the system would be incapable of capturing 100% of the application performance data that was handling account-level application performance management or enforcing SLAs. Once we discovered XPM Lightstep, they immediately recognized it as a solution capable of handling the complexity of our multidimensional performance data running across the entire distributed systems. We quickly scrapped plans to build our own solution. We didn't want to delay the availability of valuable insights by reinventing a wheel that Lightstep had already built. We take our commitments to customers very seriously and only rely on best-in-class technologies that deliver enterprise-wide visibility and scalability. There's total cost of ownership of a system. We should be shooting for 5 to 10x return on investment on every engineer. We originally thought building a performance management solution was a great use of engineering resources. Then we found XPM and realized we'd not only save a significant amount of engineering time and money by using the product, but would also benefit from Lightstep's support and superior feature set. We have over 1 million customers today. With XPM, we can prioritize remediation for our most important customers and give them customized insight and reliability. By using XPM, we don't have to sift through huge volumes of log data to identify performance tracers, which is cost prohibitive and time consuming. XPM enables us to look at data at the account level and deliver alerts to account managers and customer success managers in real time when potential latency issues arise. We can proactively work with customers to deliver premium service and remediate problems before they impact business operations. Let's take a look at our results. With Lightstep, we found we were able to achieve a 92% reduction in mean time to recovery, or MTTR. For complex failure cases, we're seeing an order of magnitude decrease in MTTR. This is saving countless hours in triage to identify and remediate issues in downstream dependent services. When we extended the product to the billing transaction engineering team, with an hour of running XPM, they were able to identify issues and deliver improvements that led to a 70% reduction in latency. This is because XPM not only detects performance bottlenecks, but it helped illustrate where they occurred, and we could then direct appropriate resources to the module or service and provide fixes. While lower latency and downtime translates into quantified business metrics, maintaining and improving customer confidence is an even bigger win. Operational excellence builds customer confidence. If our systems go down, we lose trust. XPM helps us to reduce latency and build trust by delivering on our mission to provide the features customers want and the quality they deserve. The Twilio mantra is to detect failures before they impact your customer. We invest heavily in game days, where we utilize a tool called Gremlin in conjunction with Lightstep. We have layers of tooling that we utilize to break our products in all kinds of interesting ways before we put them in the hands of our customers. Again, our focus is always on operational excellence to improve our customer confidence. With tools like Lightstep and Gremlin, from the chaos standpoint, we can introduce a multitude of controlled failures and get a visualization of how things break. Now let's hand it over to Dennis so he can talk a little bit more about Lightstep.
Thanks, Tyler, so much for sharing Twilio's journey with Lightstep. So in this next part of the webinar, I want to give all of you a short overview and demo of XPM. So just give me a second while I show my screen. See, just one second. Great. So also I want to talk about the polling question from the beginning. And we have another poll question for you to ask you where you see your adoption or your usage of microservices over the coming year. And I just want to talk about the results from the first one, which is actually very interesting because while you answer this one, because I think the answers are quite representative of how many of our current customers or many of our engagements are with people who are interested in Lightstep. 35% of you noted that you currently are deploying some form of microservices in production, while 24% of you answered that you have plans, but currently no work has been formally completed yet or done. And what's very interesting is that we're also seeing this in many of the people who are just learning about our product. Obviously, many very mature organizations like Twilio who are very active in using microservices, and it's a core part of their platform, certainly rely on Lightstep to show them these end-to-end traces across their different service boundaries, follow their microservices throughout their application. But also many organizations are just starting to think about this and adopt the use of microservices, and really they're in their migration process, they're thinking about what are the platforms that they want to adopt in the future as they make this transition. And this is something that we see a lot as well, and certainly something that we help many organizations in this transition and migration to microservices. So with that, let's get started with this introduction to Lightstep. So Lightstep XPM is really the industry's first and only performance management solution. And what makes it truly unique is that it's designed to capture 100% of performance data. But not only this, it does so 100% of the time in production with no upfront data sampling whatsoever. And what this means is that XPM collects and analyzes every single long tail sample, every outlier throughout your entire system. So it really never misses the 1 in a million anomalies. And these are really the ones that are the most interesting to investigate because they can really be precursors to something that can lead to more serious failures or more serious service interruptions. And with this 100% visibility into your application's transactions, XPM really enables organizations to see everything, to be able to diagnose anything across any axis That's really important from a business perspective. And this is how we define performance management for the microservices era. And as we've all seen, even from the polling question earlier, there's really this surge in adoption of microservices across every industry sector. And the problem with this, it's really broken the traditional APM model. As you can see in a recent Gartner report, this was just recently in March of this year, Gartner stated that these traditional tools were purpose-built for monolithic applications, and they're really not well suited to the dynamism, modularity, and scale of microservice-based applications. And it's really this ephemeral nature of microservices that makes them really hard to capture. But at the same time, if you don't capture them and see how they're affecting the overall, what their overall effect is within your application, then that could be a serious problem. So with that, I want to quickly transition over to a quick demo. Let me refresh this environment real quick. So I really like to land on this view because anyone who's done any form of used any form of time series monitoring tool will be familiar with this form of dashboard screen. So in this example, this is a dashboard that shows maybe some high-level system health information about an application. So we have one chart showing the latency, the operation rates, and error percentages for the database. We have one example here around iOS client-initiated requests, and a third one around just a low-level authentication service. So maybe the service is very crucial to the operation of the overall application, so we also want to make sure to keep tabs on what's going on with this particular service. Now, the first thing we might notice here is that when we look at the database, things seem fairly steady. There's no spikes in the latency, there's no errors, so everything looks quite normal and as we would expect it to. However, as soon as we jump over to the iOS client request, now we start to see some unusual spikes. And we really want to look more closely into what is causing these spikes. So we can focus in on a particular time range, and we can also drill into this chart to learn more about what's going on. Now, when we drill into this chart, you'll see a number of green dots. These green dots are traces that XPM has collected and recorded. You can once recorded these trace information, they're persisted, so you can review them at any time. You can go back in time and look at traces that have been recorded. And these traces are interesting events like drops in throughput or sudden spikes in latencies or errors that are occurring throughout your application. One thing that I want to point out when you look at this chart is we also show you 4 different latency bands: the P50, the P95, the P99, and the P99.9. And actually, what's very interesting is if you look at the P95 and the P50, you wouldn't really notice any changes. But when you start to look at the outliers, these P99.9s, in fact, we can even filter to just show even higher ones, these like P99.9s. Doesn't look like there's any in this range. But these outliers, like this P99.97, are really the ones that could be very problematic for a very large percentage of the user base, because these services could have some serious downstream effects which are touching dozens or hundreds of other services or calls. So they can actually end up becoming like a P50 for something that affects a large percentage of the user base. Now we want to click into one of these high latency examples, and when we do so, we see this Minimap representation in our end-to-end trace view. Now these different colors represent different services, so you can see when things are crossing various service boundaries. And this yellow line here represents the critical path, or the sequence that contributes to the overall time it takes to complete an operation. This is really the bottlenecks for this particular operation. And when we click on this, we instantly XPM instantly takes you to the particular operation that is causing this slowdown, or this bottleneck within this overall trace. So it's very easy to see where the latency issues are, where the problem areas are. But not only this, if you look on the right-hand side, we provide contextual information about this particular issue, this particular operation. So we have contextual tag information. Now tags are metadata that you can use to segment these different operations. And we see that this particular operation is tied to a certain customer ID. In this case, this customer BMO. And we can also show you things like which part of the data center is affected by this call, or this call is going through, and also log information that you can tie to this each individual operation or service. And as Tyler mentioned, one of the core use cases of XPM is this ability to be able to segment all of this information and to be able to dissect different facets of your application, so you can really understand why an application is behaving the way it is, and to understand these complex interactions across service boundaries. In fact, if you look at this Minimap, this particular issue is an iOS client-initiated operation, and you can move up and down and see all the different other service calls that it makes, and back up to the initiating call itself. So it actually goes from the mobile client all the way down to these very low-level database calls, and then back up to the mobile client itself. So you see these end-to-end, complete end-to-end traces. Now I talked about segmenting your data. So a very common use case would be to look at this issue and see that it's affecting one of our VIP clients, in this case again BMO, and we can jump to dashboards that can be created that segment your data based on these different customer ID tags. So again, this example is fairly simple one, where we just have two customers and perhaps a more general segmentation of the traffic to all the other non-paying customers that you still care about, but perhaps not so much as the high value ones. Now, one thing we see here is by being able to segment out your traffic in such a way, you can make very quick comparisons and correlate this information. So for example, here I see Acme and our general traffic, the latencies are quite similar. So that's a good sign, except for BMO, as we saw earlier. Now we're starting to again see that there's this increased latency, which we saw previously. But not only that, we're also seeing some errors in the transactions that are related to BMO. And one thing that XPM allows you to do is even not only can you segment your traffic in such a way, but we really have no limitations to the cardinality or how fine-grained you segment out this data. In fact, many of our customers create like even more specialized dashboards tied to specific customers, or even tied to like different dev build environments, different product versions, different releases, and so on. So in this example here, we can see that this customer BMO, we can tie not only the transactions related to BMO, but for example, segment out things from what mobile clients, where the requests are coming from mobile clients to web applications, specific services that are involved in these transactions for BMO, or even down to like individual operations. So, for example, if BMO relies on this example company to perform a payment charge or to reserve some asset for their e-commerce platform, then we can monitor these very high value operations to see exactly what the issue is. So as I mentioned earlier, when we saw BMO, not only did we see this latency issue that we were able to very quickly jump to the critical path, but we also started to see some errors in the traffic tied to BMO. So when we drill into one of these examples, this is the authentication service, which is crucial to a lot of the transactions, quite a low level operation. We start to see these red dots alongside the green dots. And these red dots are traces that contain some error condition. Now we can click on one of these error conditions. And one thing you'll notice is you see the same Minimap, the same trace view, but will immediately bring you to the specific operation that contains this error. And it's also, you can also visually see where it fits in this overall end-to-end trace, because it will be designated in red. Again, the tags will contain information tied to the specific service. And we also, again, have the logs showing you the error results that are included with the logs. When we see the error, you can move up and down to see what initiated this call that had an error, because that's likely that there's an effect on, for example, this API request, this charge request. And when we do so, we have that context of what specific issue may be affected by this error. So we can see that we can even have the granularity of specific charge IDs or regions, really any richness of data that would be valuable for you can be included. And then you can segment this out even further. Logs can also be included you can also have structured payload information. In this case, since this is a credit card charge, you can have things like the CCV hash, the user who made the charge. So really a very rich environment to make it easy to diagnose problems. Now, lastly, I want to just go back to the previous chart, because we also want to make it easy for you to know when these issues are a problem. So in the previous example, you can once again filter on the highest problem areas, so you can see just like the P99.9s, but we also want to be able to create alerts and conditions so that when there are these very interesting events that exceed your desired threshold, you can do so. So let's just use an example for errors, because in this example we were seeing some errors with this particular service, and obviously the next time we see this, we want to get ahead of it more proactively. So we can create a condition on the error percentage, say, just call it errors in auth service or BMO. And right now it's 2%. We can just say anything over 0.5% is unacceptable over the last 2 minutes. You can add alerting rules. We have native integrations with PagerDuty and Slack. And you can also send custom JSON webhook notifications as well. But for now, I have Slack set up. So let's just put the interval to be 2. We'll create this. And now you'll see that we show you where the error threshold is, and obviously the error percentage is beyond this. So we will get notified in Slack. And let me just pop over to Slack real quick. And as you can see right here, we have this new alert showing you the condition has been violated. But not only do we get this alert, it actually provides a lot of context. So it's not just pinging you about some problem. It'll tell you the project that this condition is violated, but also things like example traces. So you can go straight from Slack straight to a trace that is happening right now that caused this condition. So as you can see, you can jump straight to this this error here. And what's actually very interesting is XPM is actually still assembling this trace. So this is something that is happening. This is not something that happened hours or weeks or even minutes ago. This is actually something that is ongoing right now in your environment. So you can diagnose problems very quickly as they occur. And this really allows you to look and explore different facets of your application to understand very complex interactions and explain the behavior that you're seeing within your application. So that's just a very quick demo of Lightstep XPM. And I want to transition back to the slides for a moment. So I want to talk about how XPM allows our customers, or how it's designed to capture 100% of data all the time in production, because this is really the very unique fundamental aspect of XPM and why it's really critical to do so for microservice-based architectures. And it's actually rooted in the way that XPM is designed through this satellite architecture. These satellites are within a the customer's own environment. And by doing so through this architecture, our customers use XPM to analyze 100 times, even 1,000 times as much data as their next largest monitoring solution is capable of. We quite literally go through billions of microservice calls and close to petabytes of data a day for not all of our customers, for individual customers. And this architecture of XPM really has two primary components. And the first are these satellites that you see across the middle. These run within your data center, as I mentioned. And what's unique is that they collect unsampled performance data from every service, every client, every server that make up the overall application. And this is very important because if you're doing any upfront sampling, then you miss these outliers, these P99.999s, or these like rare anomalous errors. And that can be very bad because then your actual latency your actual latency distribution could look very different than what's actually going on. And this data can be collected from any cloud platform. We have client libraries for almost every language, so you can instrument your application to send this performance data in whatever way that's really easiest for you. Now, to handle this volume of data, the satellites buffer all this information in memory, but they do so long enough to compute all of the statistics and necessary data to create these end-to-end traces. They scale horizontally very easily and can be deployed in any environment that supports Docker images, AWS AMIs, or Debian packages, including Kubernetes. They can also be configured to scrub confidential or sensitive information like PII before any of this information leaves the customer environment, because this is very important. We have customers who may care very much, or they're in some regulated industry, like in the financial sector or the medical sector. So this isn't a problem at all. Now, the second component that's really at the heart of XPM is the Lightstep engine. And this is our SaaS engine, which assembles the end-to-end traces by correlating all of this collected data that's distributed across the satellites. So it selectively goes and picks and weaves this data and combines them, because this information may come asynchronously. And a single transaction may have information that's coming from very disparate parts of your application. So it has to go in and create these end-to-end traces to tell these meaningful point-in-time stories about the application. But it analyzes every single operation when assembling these traces. So it never misses these very interesting spikes and latencies or errors. But it also captures just normal traces so that you have some basis for comparison. These spikes you can compare to more normal traffic to make it much more, much easier to diagnose what the differences are and do the root cause analysis for them. And this architecture is what makes XPM truly unique, because it allows it to monitor very complex transactions that span every layer through monoliths and microservices, web and mobile clients. Now, I also want to point out that XPM integrates natively with many key technologies and leading communications and dashboarding tools, because really our philosophy is we want to provide this data for our customers in the way that they want to see it and when they need it as part of their existing standard workflow. This is something that we'll continue to focus heavily on, because it's really about making the understanding and diagnosing of problems more easily, and we don't want to create any unnecessary hurdles. So really seamlessly integrate with technologies that are popular and heavily adopted is a key focus of ours. Now, before I end, I also want to give a little bit of background about Lightstep, the company. Lightstep is founded by former Googlers with very deep expertise in performance monitoring. Our CEO, Ben Sigelman, built Dapper from prototyping the concept to building out the team behind it. He authored the technical report on it in 2010, which outlines their overall approach to understanding system behavior and performance monitoring for Google search. It's really the conceptual ancestor for open source tools like Zipkin and Jaeger, as well as commercial ones like AWS's X-Ray. We're well funded by well-known top-tier VCs with successful track records. I'm sure many of you recognize many of these. And all of our customers use us in production. And as a company, I can say we're all truly humbled and deeply grateful that so many of our customers are willing to share publicly their successes in using our product, like you heard from Tyler today on behalf of Twilio. We're really excited that this number is growing quickly, so stay tuned, because we'll definitely be sharing many more of these stories in the months to come. So I hope you enjoyed this webinar that focuses on our first core product, Lightstep XPM today. Thank you so much for joining us. We really appreciate your attendance and interest in Lightstep. And for more information about our product, you can always visit us at lightstep.com. And also in the handout section, we shared some materials that you might be interested in that goes into some more details that we weren't able to cover. And so now we'll take a few questions.
Great, thanks, Dennis. Yep, so we're going to open the webinar to any questions. Again, if you have anything you want to ask, you can do so using the control panel's question tab. This first question is for Tyler. How is Lightstep integrated into your engineering process and workflow?
Sure, that's a great question. And I think the way to best answer this is to talk a little bit about sort of the genesis of Lightstep and how it relates directly to the teams that I work with, and then overall with Twilio as a company. And I think the first thing to look at is my teams are programmable video teams. Were early adopters of Lightstep inside of Twilio. And we're excited by the opportunity of being able to go in and instrument and add tracing to the sort of complex distributed systems that we had inside of programmable video. You can imagine like joining we call it a video room or setting up a video call. There's a lot of steps to that, and there's a lot of systems that these messages that were orchestration messages would have to pass through. You can imagine authorization, authentication, that has to hit a number of systems, creating the room, orchestrating the room, adding participants to the room. These are all the number of distributed systems. And so what we did is started adding the tracing to all these systems, and we started watching. And we started watching and looking at sort of that, that 99th percentile and what does the latency look like. And then really we started honing in on the outliers. And we'd find these outliers. And what, one of the really nice things that Dennis highlighted is part of your tracing is you can actually add tags. And so you can add rich information about the traces or to the traces that are business specific to your business or specific to your processes. And so as we would highlight one of those outliers, we would pull the information out that we needed to help identify one of these rooms. And one of the ways we identify these, we use sort of like SIDs or GUIDs, and we could take those and look through our systems and then figure out by the highlighted spans of the showing the latency, sort of exactly what was going on, and really hone in on what was happening inside of that system that was causing that latency. And so that was sort of our first, our first experience with Lightstep and how we started to derive value. And so then the next step is we like to break our systems before we ever put them into the hands of our customers. And so we do a lot of chaos engineering. We use a tool like Gremlin, and using a tool like Gremlin in conjunction with Lightstep is, we can get together on a game day. We can sit down. We put Lightstep up on the board. We put our other operational dashboards on the board, and then we tell Gremlin, okay, we just start breaking things. And then we really want to see sort of, visually what is lighting up, where are we seeing latency, what systems are showing latency, and being able to visualize that through Lightstep, really makes it easy for us to sort of hone in on what happens when things go wrong. I mean, obviously we're in the cloud, so as we know, when you're in the cloud, operating the cloud, everything is going to break at some point in time. And so through a process of our game days in conjunction with Lightstep, that gave us a ton of visualization, gave us the ability to start creating those alerts, those SLA alerts. So we have all of that stuff integrated into PagerDuty and Slack. And so you'll see in our specific channels for incidents and sort of performance monitoring, Lightstep pushing rich information in there. So if incidents are triggered, we immediately show up on a Slack channel. All that information is there for us from Lightstep to help us identify issues. And so in conjunction with sort of my teams and what we've experienced with it and the value we were getting out of it, we have a program here or a process inside of Twilio called OMM, or Operational Maturity Model. And that is a program that all teams that are pushing product into production must follow, and they must adhere to this program. And the program is comprised of a number of different dimensions. One of the dimensions where Lightstep sits is the operations dimension. And you have policies inside that operations dimension, and we have a specific policy literally called Lightstep. And there's a number of check boxes that teams have to go in and check off in order to get a specific grade or reach a specific grade, with the highest grade for OMM being Ironman for any given dimension. And so in order for any team to go into production and claim general availability, they have to actually have implemented Lightstep. They have to use Lightstep as part of their game days, and they have to achieve Ironman by going through a number of sort of check boxes of different ways of implementing it and showing the maturity of implementation of Lightstep in order to push their product into GA. And so that's how we typically use it inside of, or how we use it inside of Twilio.
Great. So when your team first considered using Lightstep, was there any initial resistance in using the tool? And if so, how did you overcome this?
I mean, I think, anytime you try to introduce new tooling to engineers, there's almost always going to be some level of resistance, right? I mean, everybody has more work on their plates or in their backlogs than they can handle. And then somebody shows up and says, hey, here's this really cool tool and you should try it. It's always met with a healthy dose of skepticism. What we did is there were some early adopter, some teams that were sort of early adopters that really derived, incredible value from utilizing Lightstep. And the results of that value, we were able to articulate and show to other teams that may have been detractors or not necessarily were kind of skeptics, and show them how we were able to utilize that and solve production level issues and help us on the operational excellence front and deliver that high level of operational maturity to our customers.
Great, thanks, Tyler. So before we go, I just want to quickly throw it back to you and Dennis for one final thought or key takeaway you would like to leave our attendees with today.
Sure.
Go
ahead.
Okay, I can go first. So yeah, I think a key takeaway, and this is just based on a lot of first conversations I had with prospective customers or even our customers when they first think about Lightstep, is just think about what are some of the current processes that you're going through when monitoring your application performance. I think something that we see a lot are either struggles as they're more heavily adopting these microservice-based architectures and adding more and more of these services, is just the explosion of data that they're getting. So many of our customers, they're actually struggling with they have collecting a lot of log data, aggregating it, but really trying to make sense of all of this information is very difficult. We also see a lot of people who use, say, agent-based monitoring solutions, and when faced with all of this added traffic and transaction, then either they're forced to sample more heavily or really add a big burden on a lot of these agents, causing an overall performance impact to how they operate. And the very unique thing about XPM is it collects all of this information, it correlates them, but also it takes away that burden of the agent-based systems that are running on these various hosts. And another thing is, because we're not doing any sampling, and I think this is a very key part of why a lot of existing tools just don't work for many organizations, is because the sampling is in effect sampling out the very interesting information that they care about. So my last takeaway is I would just think about what are some of the challenges that you're currently facing, and think about whether it's related to just being able to collect and correlate all of the information that you really care about your application, and not having that when you need it, when issues arise. Any parting thoughts, Tyler?
Sure. I mean, I think, when you look at what us as platform providers at Twilio or service providers at Twilio, strive to deliver, it's operational excellence. It's trust for our customers. Our customers have to trust us to operate our services well and efficiently, and provide application level performance that meets and exceeds their expectations. I mean, we have customers that are building mission critical, life critical services on top of the Twilio platform. And Lightstep has really helped us in that mission of delivering operational excellence. It helps us to visualize application performance. It helps us to find those outliers that in small numbers are affecting only a small amount of customers, but in the large numbers, when your sample size is in the millions, and you have outliers that are in the thousands, that's potentially 1,000 calls of people having a bad experience. And we really utilize Lightstep to sort of help us hone in on those outliers, hone in on those issues that are causing bottlenecks, so we can provide great experiences for our customers. So I think that, it's become a core tenet of our operational maturity model. It has its own policy. It's highly important for all teams inside of Twilio to implement this. And I suggest other folks, if you're not looking at it now, to really sit back and say, why am I not looking at this type of information? Why am I not sort of honing in on where bottlenecks are occurring when they are occurring, and why am I not using something like Lightstep to do that?
Great. Well, thank you both for a great presentation. Again, that was Tyler Wells, Director of Engineering at Twilio, and Dennis Chu, Director of Product Marketing at Lightstep. And I would like to thank Lightstep for sponsoring today's webinar, as well as the attendees for joining us today. Until next time, I'm Christina Cardoza with SD Time.